Hi everyone, today we are going to learn CBSE Class 9 Motion chapter. Let us understand what are rest and motion through differentiation. The key words here are position, time and surroundings. When we define rest, if the position of an object does not change with time and surroundings, it is said to be at rest. Any object around, if you notice, like a building, tree, a car in the parking, comes under the examples of an object at rest. Similarly, now the words position, time changes. If the position of an object changes with time and surroundings, it is said to be in motion. The examples, any moving object we can take, like a moving car, a flying plane, a running boy, etc. Let's have a look at distance and displacement. What is distance? The total path covered by an object during its journey is called distance. If you have taken 2 points A and B, the total path covered from A to B is called distance. Similarly, the displacement, the shortest path between initial and final positions of an object in the given direction. So be mindful, when we are talking about distance, we didn't mention anything about direction. But in the displacement, direction is mentioned. It's a keyword. Similarly, distance is a scalar quantity as it has only magnitude but no direction. Similarly, displacement is a vector quantity since it has both magnitude and direction. Distance can never be zero because distance is always positive. If an object has covered certain distance, it has to have certain value, that is obviously positive. Whereas displacement can be zero, positive or negative. It depends on the path followed by the object. Whereas displacement does not depend on the path followed by the object. If you see this illustration, point A, point B, a person started from point A reaching point B. So if he is moving this way or this way, multiple paths we can take to reach from A to B. So those are all different paths which come under distance. Whereas the shortest path between A and B is along this direction in a given direction, that is called displacement. Now we'll look at what is uniform motion. If an object covers equal distances in equal time intervals, it is said to be in uniform motion. Example, a boy covering 5 meter for every 10 seconds. So 5 meter in first 10 seconds, again 5 meter in next 10 seconds, 5 meter again in next 10 seconds. That means he is covering equal distance in equal time intervals. Then he is said to be in uniform motion. Similarly, non-uniform motion, if an object covers unequal distances in equal time intervals, or the other way, equal distances in unequal time intervals, it is said to be in non-uniform motion. You can see the diagram here. The boy is covering 2 meter in 5 seconds and 5 meter in next 5 seconds, 7 meter in next 5 seconds. That means the distances are unequal, whereas time is same. That means time interval is equal. So the boy is said to be in now non-uniform motion. Next one, speed. The distance traveled per second by a moving object is called its speed. So simply speaking, speed is equal to distance upon time. So we denote distance with S, speed with V and time with small t. So usually we remember in a small triangular form to avoid confusion. when we are applying this formula for the numerical. So V is equal to distance over time upside down fraction side by side multiplication. So distance, if you want to calculate, side by side V and T are there, which can give multiplication. Similarly, when you want to find the time, distance over time. Speed is measured in meter per second. So which we write ms power negative 1, because distance is measured in meter, time is measured in second. The old unit which we need to know, CGS, centimeter, gram and second system, which is nothing but centimeter per second. It is always good to know both SI and CGS units for any physical quantity in physics. Speed is a scalar quantity since it has only magnitude but no direction. In case to find the average speed of an object which covers different distances over a period of time, we need to calculate the total distance covered by total time taken to obtain average speed of the body or object. We use a device called speedometer in order to measure the instantaneous speed of the vehicle. Similarly, the device that we use to measure the distance or the displacement covered by an object or vehicle is called odometer. So you can see the diagram for speedometer and odometer in our regular automobiles like car, bus, truck, etc. It looks like this. It ranges from 0 to, depends on the type of the vehicle, the speed will vary in kilometer per hour. Kilometer per hour, the speed is mentioned. You can see here 0, 20, 40, 60, 80, 100, 120, 140, 160, 180. This is the speedometer. The needle or the pointer shows as per the movement of the vehicle. Here if you notice, the odometer which records the distance covered by the vehicle during its journey from one point to another, the total time, the total distance covered by the vehicle over a period of time, that is given in kilometers. Next, coming to the point of velocity, there is a slight change compared to speed because we need to mention the direction. That is the keyword here. The distance traveled per second by a moving object in a particular direction. We have to add about direction here when we are defining the velocity. Is called its velocity. So velocity is equal to displacement over time. Displacement usually we denote with S letter with a bar on top which denotes the vector. Even for velocity we denote a vector with V bar. V bar is equal to displacement by time. We follow the same pattern like speed, distance, time in order to remember the formula for velocity, displacement and time. So both speed and velocity are measured in meter per second as SI unit, and again CGS unit is centimeter per second. As direction is mentioned in velocity, it is a vector quantity. If the velocity of an object is changing at a uniform rate, then the average velocity can be found by taking u plus v by 2, which is nothing but the arithmetic mean of the velocities. So here u indicates initial velocity of the body and v indicates the final velocity. So here both speed and velocity can also be measured in another unit called kilometer per hour. So which is indicated by km h power negative 1 or h inverse kilometer per hour. But this is not either SI or CGS unit. It is another unit to measure both the speed and velocity. So keep this point in mind, students. How to convert kmph, kilometer per hour, into meter per second? So simple, it is nothing but multiplying the given value with 5 by 18. Some of you might wonder, why are we taking 5 by 18 only? Because when you convert the kilometer, 1 kilometer is 1000 meter upon 1 hour is 3600 seconds. So if you simplify this, you will get 2 table here 5 times and 18 times in 36. That's how we get 5 upon 18. So you might wonder, why are we particular about 5 by 18? This is why we are taking the value of 5 by 18 to convert from kilometer per hour into meter per second. Example is very clear. 72 kilometer per hour into meter per second. Multiplying with 5 by 18, the value is 20 meter per second. In the same way, to convert meter per second into kilometer per hour, we have to just inverse that fraction into 18 by 5. So example has been given here, 35 times 18 by 5, which is 126 kilometer per hour. Next one is about acceleration. The rate of change in velocity of an object is called its acceleration. Means if the velocity of an object, suppose if we are accelerating the car speed is changing from 20, 30, 40 like that, it is going up to 100 kilometer per hour. That means the car is getting accelerated. So in this scenario, change in velocity by time will be taken to calculate the acceleration. If you notice here, like velocity, we also wrote a vectorial form here for acceleration, because acceleration is also a vector quantity. So a bar is equal to v bar minus u bar by t. But whenever we are doing the numerical, we usually take uv like that. You never mentioned about that bar on the top. Initial velocity for u, final velocity is for v, and time taken is small t we measure. What is the SI unit of acceleration here? For velocity we already know, which is meter per second by time again second. So meter per second square is the SI unit for acceleration. Similarly, instead of meter per second, if you take centimeter per second as the CGS unit for velocity, and again second for time, centimeter per second square is the CGS unit for acceleration. As I earlier mentioned, acceleration is a vector quantity since it has both magnitude and direction. If the velocity of the body decreases with time, it's not necessary that when we write the word change in velocity, it doesn't always means velocity has to be increased. Velocity may also decrease. In this scenario, we say if the velocity of the body decreases with time, the motion is said to be decelerated or retarded. Nothing but retardation. Negative acceleration is also called retardation. I hope this is clear to all of you. Thank you.